Okay, so we're in the last section of Chapter 1. It's 1.4, Presenting Scientific Data. So, in order for news to be useful, it must be reported in a clear, organized manner. Like the news, scientific data becomes meaningful only when they are organized and communicated. Communication includes visual representations such as this graph. How do scientists organize data? Scientists can organize their data by using data tables and graphs. The simplest way to organize data is to present them in a table. This table relates two variables, a manipulated variable, which is location, and a responding variable, average annual precipitation, so how much rain they get. A line graph is useful for showing changes that occur in related variables. In a line graph, the manipulated variable is plotted on the horizontal or x-axis. The responding variable is plotted on the vertical axis or y-axis of the graph. Sometimes the data points in a graph yield a straight line. The steepness or slope of this line is the ratio of a vertical change to the corresponding horizontal change. The formula for the slope of a line is rise over run. Plotting the mass of water against the volume of water yields a straight line. So here we got volume on the x, mass on the y, and then we take a point here and we go up 5 and over 5. So we go run 5, rise 5. But rise divided by run equals 1. 5 divided by 5. A direct proportion is a relationship in which the ratio of two variables is constant. The relationship between the mass and volume of water is an example of a direct proportion. A 3 cubic centimeter sample of water has a mass of 3 grams. A 6 cubic centimeter sample of water has a mass of 6 grams. A 9 cubic centimeter sample of water has a mass of 9 grams. But this is a direct proportion. These two numbers go up at the same rate. This graph shows how the flow rate of a water faucet affects the time required to fill a 1-gallon pot. So, if the flow rate is small, it takes longer. So flow rate is here. That's on the x. Time is on the y. It takes 4 minutes when the flow rate is less than 0.5 gallons per minute. At 0.5 gallons per minute, it's 2. At 1 gallon per minute, it's 1. At 2 gallons per minute, it's 0.5. So this relationship is, as this number gets bigger, your y-axis number gets smaller. We call that an inverse proportion. An inverse proportion is a relationship in which the product of two variables is a constant. They just go in different directions. The flow, and then we talked about this already, flow rate of half a gallon is 2 minutes, 1 gallon is 1 minute, 2 gallons is half a minute. Organizing data, bar graphs. A bar graph is often used to compare a set of measurements, amounts, or changes. So, as you can see, Buffalo is here, Chicago is here, and then you can very quickly look and see Tallahassee has the greatest average annual precipitation, and San Diego has the smallest. Instead of looking at the numbers, you use the bar graph to show that data. Circle graphs, if you think of a pie cut into pieces, you have a mental model of a circle graph. A circle graph shows how a part or share of something relates to a whole. This shows that most of the Earth's crust is oxygen, and the least amount is either other or magnesium. So then this shows you really quick how you can find which one's the most and which one's the least. How can scientists communicate experimental data? Scientists can communicate results by writing in scientific journals or speaking at conferences. Scientists often exchange information through conversations, emails, and websites. Young scientists often present their research at science fairs. Peer review is a process in which scientists examine other scientists' work. Peer review encourages comments, suggestions, questions, and criticism from other scientists. Based on their peers' responses, the scientists who submitted their work for review can then reevaluate how to best interpret their data.